Hi all, today's video is with respect to eSync Alliance. When the software defined vehicle, the concept comes into our mind, what are all the fundamental aspects of SDV? So the idea is that you make a car, you sell it to the customer, you get the real time data out of it, you diagnose the bugs, the engineer immediately gets the feedback with respect to the performance of it. He uh, he or she fixes the bugs which are detected. Then a automated pipeline of this EACD, which basically does all the testings, which I have explained in my former earlier videos. You can have a look. I will tag them in the description of this video. And then we basically release the software and which makes the car better over a period of time. So for this to happen, the fundamental aspects which are actually important is with respect to the connectivity. So that is what we are talking about. So once this connectivity and everything is enabled, once this pipeline is in place, the OEMs or the tier 1 suppliers or any other third party developers can basically extract important insights and provide valuable applications for the end customer for making his life better with respect to, like, we can take a small example of a ball joint which is basically available in the car, in the steering system. So here basically just by plugging in a a sensor for this particular ball joint, we can basically create a lot of new functionalities or maybe a lot of new applications which actually add value to the customer over a period of time. So it could be with respect to predictive maintenance or height leveling or whatever it is, which basically add more of a value to the customer. So in order for all of this to happen, the fundamental point which is actually needed to realize this is connectivity. So as long as the car is connected, secured, then the OEMs, third tier 1 suppliers or the customers or the OEMs, the suppliers, the third party app providers, they can extract value out of it and they can uh, show the value to the customer, which makes his life better. So as of now, the current scenario is something like this. You do have a lot of OEMs, you do have a lot of the suppliers, and they. What actually happens over here is all of these OEMs or all of these suppliers are not following a single standard. Everyone has their own way of getting things done. But in reality, the connectivity as such is not adding any value to the end customer. I'm not talking about with respect to the security threats, vulnerability, connectivity, and other things, but in general, connectivity as such does not add much of value rather than the applications which are extracted by having this connectivity and getting this entire loop running. So as of now, this is the current scenario where you have OEMs, they have their own standards. There are these suppliers who have their own standards, and there is a lot of what to say dependencies, and there is no in how do I put it into words? Yeah, so there is no compatibility between, there is no guarantee that each of this device can be compatible just like that immediately. Like say BMW is taking an Aptiv device, and if at all they have to switch from Aptiv to Hella, then it might not be a cakewalk for them just like that, because there is no standardization which is over here, and there is no guarantee that whatever these guys are supplying, they support the operating systems or the underlying other aspects as well. Say some OEM is working on Android Auto and another one is working on Linux for their own infotainment systems, and they want this connectivity aspects into that. So with respect to the OS also, there might be some deviations with respect to uh, lack of standards. So in order to avoid this kind of thing, eSync basically what it provides is, it is what they're talking is a bidirectional data pipeline which has a standardized how do I put it? So it has its own standard practices when followed, then can basically make the systems interoperable. So they are basically providing an architectural specifications, minimum feature specifications, providing a APIs, means how the API should be, how the architecture should be, so that once the OEMs and the makers, they basically follow it, then there is a capability of having a lot of interoperability, and which does not make them stick to one particular vendor as such. So this eSync, what they are speaking is with respect to agnostic of the cloud infrastructure, like say BMW, they are currently having AWS as their cloud provider, and if at all they have to switch from AWS to maybe Google Cloud or maybe Azure, then as per this architecture, whichever they are specifying, so it is cloud agnostic. So it doesn't matter whether you switch from AWS to Azure or whatever, and that should not make much of a difference for you, or maybe a private cloud as such, which BMW might be having. Similarly, for the operating system, so you have Android now, and say some other vendor is having a Linux or something else, then the interoperability is also taken care with respect to the operating systems as well, and not just that, even with respect to the payload and data formats as well. So eSync is basically trying to bring all the players or all the stakeholders onto a single page, so that a lot of repetitive, uh, I won't say repetitive work, but a lot of work which is being duplicated in a different form can be avoided, because at the end of the day, all these OEMs and all these suppliers, what they want is they want a proper connectivity, and they are not actually reaping much of a benefit by having their own independent standards. So it is better to have a uniform standards across, and try to extract value out of the data which is basically extracted out, like how I have explained in the former uh, former videos, I mean like the former use cases which I have just told. So this is what the importance of eSync is all about. And so let me just give you a brief overview with respect to what the architecture is, how is it designed. So basically they are having a server client agent architecture. So as an example, you have an eSync server, and your client will be your car will be your client, so it will have its own eSync client. And in the car you may have any number of ECUs, you may have 20, you may have 50, or whatever it is, and each of these ECU, whichever you want, from where you want to get the data out, are independent agents. So you can have one eSync agent, maybe your braking system, you can have one agent in the high performance computer, you can have another agent which I have explained earlier in the ball joint sensor. So these could be some separate agents as such, connected to one client, which happens to be the car, which through the gateway, and you then connect to the server. So eSync server doesn't mean that it is provided by eSync, but a server which is binding to the rules of the eSync. So that is what it means. So say there is maybe an OEM one who have one server, and there might be 10,000 cars running on the road. So you will have 10,000 clients over there, but each of the client has 50 agents of such. So these are all the devices which are basically connected. So you can add as many agents as possible. So there is a lot of flexibility and scalability with respect to that. And another good thing what the eSync group, what they have done is they are making sure that whatever the vendors or OEMs which they have spent some lot of time developing their own assets, they are not kind of obsolete after implementing eSync, but it is kind of interoperable even with respect to this. So it is the existing architecture, the existing infrastructure which is already out there. They are trying to get this thing adapted to the eSync, so that there is no significant rework which has to be done from scratch. So it is very similar to how Covesa is perceiving SDV by making the vehicle signal standards uniform across the OEM, so that there is a huge amount of interoperability. Similar to that, even the guys at eSync, they want to have this connectivity protocols and the connectivity architecture kind of uniform across all the OEMs, all the tier ones, and all the other third party vendors, whoever it is, so that over a period of time, the entire community as such can benefit out of this interoperabilityness. So, because the reason why they are doing is SDV is such a revolution which cannot be done end to end by a single company. So, for that reason, it is like people are joining hands to make a better product and to revolutionize the automotive space. So, that is the background idea. So, looking at eSync reminds me of the World Wide Web, how the World Wide Web, which was open sourced, became a standard. And we don't even know that, yeah, ideally, Tim Berners-Lee, he could have patented the World Wide Web for himself, and he could have said that, okay, fine, you pay me some amount of money and only then I will give you access. Then we will not have one World Wide Web. Each of the companies, tech titans, will have their own versions of World Wide Webs, which screws up the interoperability part. As he has open sourced the entire stuff, the explosion of growth actually happened. The actual internet growth happened because of the open sourcing of the World Wide Web, so that anyone can speak to anyone without any restriction. So maybe eSync is trying to do something in similar lines. So this is one brief overview with respect to what eSync is, what is the companies which are trying to do. Yeah, so these are the member companies which are out there who have joined hands and trying to bring this eSync to life. They have already kind of rolled it out across few countries, across OEMs and across geographies also, and they are seeing some success. But let's see if at all it is standardized and it is actually adding value to the entire ecosystem as such. So that's the end of the video, and thanks a lot for your time. Thank you all. Bye.